Most AI models lose money before they are ever used, and most companies don't even know it, because they're measuring the wrong thing. They measure inference cost, they track usage, they optimize efficiency per request, they build dashboards around outputs, but by the time those numbers appear, the economic outcome has already been decided. The real cost is already locked in. Model training is not where AI becomes useful, it is where AI becomes expensive. And once that cost is committed, the system does not get to renegotiate it. It can only justify it, or fail to. AI does not begin as a tool. It begins as capital, large, concentrated, irreversible. Training is not incremental. It does not scale gradually. It does not adjust cleanly with demand. It is a single financial event. Compute is allocated, time is consumed, cost is absorbed. And when the process ends, nothing comes back. There is no partial recovery, no residual value, no way to unwind the decision. The model exists, the capital is gone. Nothing adjusts after that. All of the cost is concentrated up front. The system absorbs it before it produces anything, and it only makes sense if that cost can be distributed across usage over time. If that distribution does not happen, the capital remains unresolved. That is the structure, and it breaks the logic of traditional software. In software, development is expensive, but deployment is almost free. The cost declines as usage increases. In AI, the largest financial event happens before the system is even used. Training is not development in the traditional sense. It is capital deployment, closer to building infrastructure than writing code. You invest first, you absorb the cost, and only afterward do you attempt to recover it. That recovery is not guaranteed, because the cost has three defining properties. It is sunk, it is front-loaded, and it depends entirely on future usage. If the system is not used enough, the cost does not adjust. If the model is replaced too early, the capital is written off. If the output does not translate into real economic value, the return never materializes. The model can perform exactly as designed and still fail economically. That is the disconnect. The system is working, the investment is not. Cheap output, expensive system. And the more efficient the system appears, the easier it becomes to miss that distinction. Because once the model is deployed, the marginal cost looks small. Each request appears inexpensive. Each response appears scalable. The system looks efficient, but that efficiency is local. The capital is global, and the capital has not yet been absorbed. It has only been deferred. This is where the illusion forms. AI systems often appear low cost after deployment, but they are only low cost if the training investment has been distributed across enough usage. If that distribution does not happen, the system is not cheap. It is incomplete. The cost exists. It just hasn't been fully allocated yet, and the longer that allocation is delayed, the more fragile the economics become. By the time the model is deployed, the outcome is already decided. Everything that follows is recovery or failure. The only mechanism that resolves this is scale. Training only makes sense when usage is large enough to absorb the initial investment, when volume spreads cost across time, when millions of interactions flatten what was spent. Without that, Each output carries an invisible burden. At scale, the cost flattens. Each additional use carries less of the original burden. Without scale, the cost stays concentrated. Each output continues to carry what was never absorbed. The system runs, but the economics remain unresolved. This is where structural asymmetry appears. Large firms can absorb this. They have distribution, they have traffic, they have sustained demand. They can spread training cost across massive volumes. Over time, the capital disappears into usage. The model becomes economically stable. Smaller firms operate under a different constraint. They face the same training cost, without the same ability to amortize it. The cost does not scale down cleanly, but usage does, which means the burden per output increases. Not because the model is worse, because the economics are tighter. This forces a decision, not how to train, but whether to train at all. Because training is not just capability, it is exposure. And there is an alternative. You do not build the model. You access it. You do not commit capital. You convert that commitment into ongoing cost. You rent intelligence instead of funding it. That does not eliminate cost. It changes its structure. One concentrates risk upfront. The other distributes it across time. One gives control, the other preserves flexibility. Neither is free, but only one avoids committing before demand is proven. And that distinction matters, because training introduces a timing distortion. Cost happens immediately. Return happens later. If it happens, and the gap between the two is uncertain. During that gap, the system appears unprofitable, not because it is failing, but because the capital has already been spent. This creates pressure to deploy early, pressure to expand use cases, pressure to assume future scale. And that pressure changes behavior. Systems are pushed into production before they are economically justified. Use cases are stretched beyond their natural fit. Performance is interpreted optimistically, because the alternative is to accept that the capital may not return. And once that pressure builds, overinvestment follows. Too many models, too much capital, too little utilization. The system expands faster than its economics, and for a period of time, everything appears stable. The model works, outputs are generated, usage increases. From the outside, nothing is wrong, but underneath, the capital is still unresolved. And time is not neutral. Because models do not depreciate slowly. They become obsolete. A new model appears. A cheaper training method changes the cost curve. A competitor produces superior output. And suddenly the original investment is no longer competitive. Not because it failed, because it was surpassed. That shift is abrupt. And when it happens, the recovery window collapses. What was expected to be recovered over years must now be recovered faster, or not at all. And if it is not, the remaining capital becomes a loss. This is where most AI investments fail. Not technically, financially. This is not a model problem. It is a capital problem. Training is not a milestone. It is a commitment to upfront cost, to future dependence on scale, to obsolescence risk, to limited recovery time. There are conditions where this works, where scale is predictable, where demand is stable, where the model becomes part of the firm's structural advantage, where it cannot be replaced or outsourced. In those cases, the capital is justified, The system stabilizes and the investment is absorbed. The economics hold. But outside of those conditions, the structure becomes fragile. The model still runs. The outputs continue, but the return does not follow. And this is where most organizations fail, not because the model does not function, because the cost was misclassified. Training is treated like experimentation, but it behaves like infrastructure. It is treated as flexible, but it is fixed. It is treated as reversible, but it is not. And that misunderstanding leads to systematic overinvestment. Too many models, too much capital, too little scale. The system continues to operate. From the outside, it appears successful, but internally the economics are misaligned. The capital was never fully recovered. And once that happens, the system stops being an advantage. It becomes a burden. Model training is not where AI becomes powerful. It is where AI becomes expensive. It is the moment where computation is converted into capital. And once that conversion happens, the system has to carry it through scale, through usage, through time. If it can, the model becomes an asset. If it cannot, the model still exists, but the economics fail.